Know if you guys can hear it or not. Yep.
How come some insects are able to walk on the surface of a pond, but you quickly sink to the bottom when you try to walk on water? And why do lakes freeze from the top down in winter? In a word, the answer to all of these questions is polarity. Water is a simple molecule made up of one oxygen atom and two hydrogen atoms, but it is essential to life. In fact, water makes up approximately 60% of the adult human being's body weight. The polarity within those water molecules gives this common substance the properties that make it unique and life-sustaining. Polarity refers to the unequal sharing of electrons within a molecule. For water, the bonding between the oxygen atom and two hydrogen atoms within a single water molecule is like a tug of war between a big, strong football player and a cute little toddler. Oxygen is a larger atom with more protons in its nucleus than hydrogen. These positive charges are like a person's physical strength. They are able to attract the negatively charged electrons in the bond, just like a strong individual is able to overpower a weaker individual in a tug of war. So, oxygen is able to attract more than its fair share of electrons. Because hydrogen is smaller and has less strength, or fewer protons, it loses the tug of war and attracts fewer than its fair share of electrons. So the oxygen in water behaves as though it's negative, and the hydrogens behave as though they're positive. The bonds within a single water molecule are called polar covalent bonds. Covalent means that the electrons are shared. But, as we just learned, polar means that these electrons are not shared equally. In water, the oxygen acts negative, and the hydrogens act positive. Since negative and positive attract, that oxygen is attracted to the hydrogen atom in neighboring water molecules. A special type of bond forms between water molecules known as a hydrogen bond. Hydrogen bonds don't just happen in water either. They can form between a water molecule and different substances that are polar or ionic. Water's ability to stick to itself is called cohesion, while water's ability to stick to other substances is called adhesion. Now, think back to the initial questions. First, why are some insects able to walk on water? Surface tension due to hydrogen bonding creates a thin film on the surface of water that gives enough resistance for super light insects to walk on. You can't walk on it because the hydrogen bonds aren't strong enough to hold you up. Why does ice float on top of liquid water? For most other substances, the solid state is more dense than the liquid state, but that is not the case for water. Hydrogen bonds keep water molecules farther apart in frozen water than in liquid water. The farther apart the molecules are, the less dense that solid is. So ice is about 9% less dense than water, which means it floats on the top. That's why lakes freeze from the top down and aquatic life is able to survive through a cold winter every year. It is the polarity of the water molecule and the resulting hydrogen bonding that account for water's unique properties. So, the reason that water is so special, from inside your cells to the world's oceans, is simply because it is a polar molecule.
Super fascinating. Yay, polar molecules. All right, so moving on. Hydrogen bonding. Okay, so she just talked about it pretty quickly. Hydrogen bonding is a result of water's polarity. So, because that oxygen is slightly negative, the hydrogen ends up being slightly positive. We know that opposites attract. So they attract, this water molecule being polar attracts other water molecules, and that attraction we refer to as a hydrogen bond. Again, the positive hydrogen is attracted to the negative oxygen, and it's a pretty weak bond because, again, this is a slight negative charge, a slight positive charge. Hydrogen bonds are not only weaker than ionic bonds, they're also weaker than covalent bonds. In fact, it's one of the weaker one of the weaker bonds that exist between chemical substances. So again, we see two water molecules here at the bottom. I don't know if you had this graphic on your notes. I don't honestly remember if I put it in there or not. But this bond that exists between them, between the slight positive, slight negative, is what we refer to as the hydrogen bond. And this hydrogen bond, going back to the video, is what creates that surface tension where now you're able to have some insects that can walk on the surface of water. All right. So, again, this is just like a quick little demonstration. So, what do you imagine was going to happen with these molecules if I heat this up? What should happen to them? Anybody? Anybody at all? Give me a prediction. What will happen with my water molecules if I heat it up? They should be moving a lot. Okay, awesome. Now we can see these slight little hydrogen bonds between the positives and the negatives, right? Between the individuals. So let's see what happens. Oh, come on. So again, if I heat this up, maybe I need to, come on, please work. There it goes. So now that's just water. And if I heat it up, they move a lot faster. And there's a lot fewer hydrogen bonds. Now, if I cool it, you see these molecules sticking to each other a lot more. That stickiness, of course, is what we refer to as the hydrogen bond. So the slower they move, the more hydrogen bonds are going to form. And big surprise, the faster they're moving, the fewer hydrogen bonds we're seeing forming. Okay? So, simple question. If you were an insect, would it be easier for you to walk on a cooler body of water or a hot body of water? Anybody? That bug that can walk on the water? Is it easier for me to walk on water, let's say in May or in like July? What do you think?
May.
Exactly, in May, because in May, the water temperature would be a lot cooler. We're just coming out of winter, and we're going to have a lot more of these hydrogen bonds. Awesome. All right, good job, guys. Okay. All right, hydrophobic, hydrophilic. Hydrophobic, hydrophilic. Hydro refers to water. Water. Phobic. I'm sure you guys all know that prefix. Suffix. Pre comes before. The suffix phobic. Phobic refers to a fear. Philic refers to love. So some things are hydrophilic. They love water. They work well with water. Some things are hydrophobic. They repel water. Okay? So water it attracts and is attracted to other polar molecules. If you are another polar substance, by the way, that also goes with ionic substances, you can dissolve them very easily in water. This is called hydrophilic. They love water. They dissolve in water. So, like, think sugar, right? Salt. If you took salt and poured it into water and spun it up, you wouldn't even see the salt anymore. It dissolves beautifully. Hydrophobic, water fearing, not that they're really afraid of water, they just don't dissolve in water, are substances that repel water. They are non polar. Fats and oils. If you've ever seen Italian salad dressing, you know this, right? Italian salad dressing, if you let it sit too long, what happens to it? Anybody?
It starts becoming nasty.
Okay, so like it's still in the fridge, it's not going to go bad. But if you let Italian dressing sit for a long time, what happens? Okay, I'm not disagreeing with you, but before you use Italian dressing, what do you always have to do with it? Shake it up. Yes, because Italian dressing is basically water, vinegar. By the way, vinegar is uh, polar. It's an organic compound, so it's water, vinegar, and then it's oil. So if you let it sit,
Basically, like the same thing with mustard and ketchup.
exactly, exactly. So so if you let the Italian dressing sit too long, the water and the vinegar sink to the bottom, and then the oil goes to the top. And before you use it, you got to shake it up because oil is hydrophobic. It repels water. Vinegar is hydrophilic. It loves water. So hydrophilic, hydrophobic. This will become more. Uh, I don't know. Does anybody else have a hard time hearing me? It's loud.
All of a sudden,
How about now? Now?
yeah, it just happened all of a sudden.
That is weird. Okay, give me a second. How about now? Okay, my
A
mic.
little bit.
Yeah, my mic is doing weird things. Just give me a second. I can see like my numbers jumping from like 100 down to like 40 for some reason.
That's better.
Okay, fantastic. All right, cool. So, hydrophobic. Again, they repel water. If ever you buy like leather shoes, especially like dudes, like I don't know if it's a girl thing for girls. I know it's a thing for my son. He often has to like treat his leather shoes with like this, I don't even know what it's called, like mink oil, I think it's called, when he buys like leather boots. So that way when he goes out in weather, they don't like the leather doesn't get ruined because oils repel water. All right, where are we? Okay, so because of this, water, again, we're talking about the polarity of water. This polarity gives it the ability to dissolve ionic compounds and other polar molecules. So this means it dissolves almost everything. Not everything, but almost everything. Most biological reactions, because again, we're 60% water, can be dissolved in water. This is hugely important for chemistry. We refer to water as the universal solvent because solvents are the things that you dissolve things in. The solute is a thing being dissolved, and then the solution is the mixture of the two. Water dissolves so many different things, so we call it the universal solvent. It actually dissolves more substances than any other liquid that we know of. So if you want to dissolve something, try water first. Doesn't dissolve everything, but it dissolves most things. Again, it is the universal solvent. All right. I think we have just enough time to do cohesion before the bell's going to ring. All right. So, again, thinking of this polarity, thinking of these hydrogen bonds because of the polarity. We saw this in the little demonstration. Cohesion is this ability of water to stick to itself. Okay. So, cohesion is really just any molecule sticking to itself, same substance. Water is really, really cohesive because of those hydrogen bonds. Water molecules are able to stick together. If you guys remember that stupid TikTok from a million years ago, why is water wet? Well, the answer is because of cohesion. That's actually, no, it's because of adhesion, but that's besides the point. We'll get to that eventually. Water will actually stick to each other because of cohesion. Cohesion is really, really important to life. And we'll get into that as we get a little further into biology. But again, this idea that this chemistry, this polar nature of this bond, this covalent bond, affects so many things um, because of the very nature of this bond. All right. That kind of takes us to the end of today. I totally forgot today was Thursday.